In this video, we will learn about elementary row operations for the matrices. There are three elementary row operations. So I will discuss those three operations here, and then I will provide examples of those operations in this side of the board. So now let's start. The first elementary row operation is called row swapping. That means if you have a row, let's say Ri, and you swap that row with another row Rj. Let's clear this operation with an example. So now let's do an example. In this example, I have a matrix which is 1, 2, 3, 1, 0, 1, minus 1, minus 2, and 7. And let's say I'm asked to swap first and the third row. That means the operation that I want to do is R1 swap with R3. So I have to basically change the location of these two rows. So my result after swapping R1 and R3 is going to be that the third row will be the first row, so it will be like minus 1, minus 2, and 7. And the first row will be the last row, so the last row is going to be 1, 2, and 3. And the second row will remain the same, 1, 0, 1. So this is an example of a row swapping operation. The second elementary row operation is called row multiplication. In row multiplication, we multiply a row with a scalar, but that scalar cannot be equals to 0. So I can say that the scalar can be negative number, that scalar can be a fraction, but it cannot be a 0. So I can say that Ri is equals to A, which is a scalar, a number, times Ri, but A cannot be equals to 0.
But why?
We will see that multiplying with 0 is basically make the matrix inconsistent. So basically it, because we want to preserve the solution presented by the matrix, and by multiplying 0 we basically destroy that solution. That will come later on. So now let's do an example of row multiplication. Example. So we have a same matrix 1, 2, 3, 1, 0, 1, minus 1, minus 2, and 7. And let's say I have to apply this operation, which is R2 is equals to 3 R2. So I have to multiply R2 by 3. So that means all the entries of R2 will multiply by 3. So my resultant matrix will be the first row will remain the same, the last row will also will remain the same, whereas in the second row all the entries of the second row will be multiplied by 3. So 1 times 3 is 3, 0 times 3 is 0, 1 times 3 is 3. So that's an example of row multiplication operation. So our final operation, because I told earlier that we have only three elementary row operations. So our final row operation is row addition. That is, in row addition, let's say I have a row I, then in the row I will add another row j, and I can also multiply that row j with some scalar, and then can add in row I. So optionally I can also multiply row row j with a scalar, and then I can add the result in row I. Once again, here a cannot be equals to 0, right? So, or if a is equal to 0 is fine, because then you are doing nothing. You're not doing any addition because it will become 0. So A can be 0, but then this operation is meaningless. You're not doing row addition. So here A cannot be 0, here A can be 0, but it will make no sense. So now let's do an example. Once again we have the same matrix, which is like 1, 2, 3, 1, 0, 1, minus 1, minus 2, and 7. And let's say I have to do an operation which is R3 is equals to R3 plus 2 times R1. So I have to multiply entries of R1 by 2, and then I have to add the result in R3. So let's do that. So if I can multiply this entry by 2, and then I will add 2 in minus 1, my result will be going to be 2 minus 1?
1.
1. So here I will have 1. Both of those rows will remain the same, so I can write them quickly maybe. 1, 2, 3, 1, 0, 1. Only the third row is changing here. So first our result is 1. Now I multiply this 2 by 2, which is 4. And then I say 4 plus minus 2, 2. And similarly I multiply 3 by 2, which is 6. And then I say 6 plus 7 is going to be 13. So I hope that you'll be able to understand these elementary row operations. They are not very difficult, but to make concepts clear, I'm going to write an example, and then I will let you to do that example.
Okay, so my father has made me some questions to do, and now I'm going to do them one by one. So let's start. In the first one, we're row swapping. So we're swapping row 1 with row 3. So let's do that. Now row 1 will be row 3. So it'll be 1, 3, and 1. Now row 3 will be row 1. And we're going to write, so like 3, 11, and 5. And I'm also going to write the second row, which will remain the same because we did nothing to it. 1, 1, and minus 1. Alright, now we're going to do the second part. In this one, we are subtracting row 2 and row 1. So let's do it. And answer will be row 2. So row 1 and row 3 will remain the same. So 1, 3, 1, 3, 11, and 5. Now this will be minused with row 1. So 1 minus 1, 0, 3, 1 minus 3 will be minus 2, and then minus 1, which will be minus 2. Okay, now we're going to do question number 3, the next question. So in this question, we're going to multiply row 1 with 3 and then subtract it from row 3. So let's do it, and the answer will be row 3. So now let's do it. Row 1 and row 2 will remain the same, so we'll just write that real quick. 1, 3, 1, and then 0, minus 2, and then minus 2. Now we're going to do the question. So 1 multiplied by 3 minus, and then 3 minus 3, which will be 0. The next one, 3 multiplied by 3, which is 9, and then 11 minus 9, which will be 2. Yeah? Okay. Now again, 3 multiplied by 1, which is going to be 3, and then 5 minus 3, which will be 2. Now let's do the next question, question number 4. In this question, it's very simple. We're going to multiply plus row 1 with row 2. So let's do it. We're going to plus row 3 and row 2. Okay. So row, and answer will be row 3. So row 1 and row 2 will remain the same. So we'll just write that 1 3 1 0 minus 2 and minus 2. Now row 3 plus row 2, and that means 1, no, it'll be, yeah, okay, 0 plus 0, which will be 0, minus 2 plus 2, minus 2 plus 2, which will cut and be also 0 once again, and then minus 2 plus 2, same thing, 0. So now we're done with this video, and we're going to see you next time. So bye! See you next time.